A popular thought experiment asks, what happens to human civilization when the machines we build evolve past the point of needing us at all? For decades, the answer has been rooted in a comforting narrative. We view automation as an advanced tool, a mechanical co-pilot designed to handle heavy lifting and repetitive assembly, freeing human beings for higher-level thinking. Modern artificial intelligence moves beyond static, pre-programmed execution. It sits in the background, observing human workers in real time, mapping their cognitive processes, and learning how they solve complex problems. This is a 2025 working paper published by the Federal Reserve Bank of Richmond. It models a concept called technological unemployment, treating the phenomenon not as science fiction, but as a measurable macroeconomic reality. The researchers outline a specific economic sequence. An AI system learns directly from an employed worker, absorbing their skills to raise productivity. Once the software matches the worker's capabilities, the firm attempts to renegotiate wages downward. If that fails, the worker is permanently displaced. We are actively training our own replacements. Across countless industries, current jobs are slowly being converted into temporary data-gathering phases for machines. Forecasts from global consulting firms project that up to 800 million jobs globally could be automated by the year 2030, putting enormous pressure on industries ranging from manufacturing to high-level knowledge work. This chart shows rising AI job shares across advanced economies. The upward slope reflects demand for AI specialists, masking the erosion of routine roles. These jagged trajectories highlight uncertainty over whether new tech roles will emerge fast enough to offset the millions of eliminated jobs. During low inflation periods or economic downturns, demand slumps. When that happens, corporations deploy artificial intelligence strictly as a cost-saving substitute, eliminating human roles to protect profit margins without creating compensating new positions. As human labor is replaced at scale, a secondary structural crisis emerges. Software and robotics skip income taxes. They do not buy cars, clothes, or groceries, meaning broader consumption drops and tax collections plummet. An unchecked transition to automated labor threatens to bankrupt the core taxation and economic structures that modern nations rely on to sustain their populations. Artificial intelligence is migrating out of factory floors and into the cognitive, decision-making spaces of our daily lives. We readily normalize interacting with machines over humans for our most basic transactions. There is no violent cinematic conflict between man and machine. Instead, we are willingly surrendering our daily autonomy, driven by an innate desire for friction-free convenience and immediate results. We are enthusiastically outsourcing highly complex, high-stakes functions to algorithms and robotics. Systems like the Da Vinci surgical robot demonstrate how even the most critical, life-and-death physical precision is being handed over to automated platforms. Researchers warn of a subtle psychological deterioration. As we increasingly rely on AI to evaluate data, screen job applicants, and navigate our routines, our fundamental cognitive capacity to exercise independent judgment slowly atrophies. In our relentless pursuit of an optimized, perfectly efficient existence, we are quietly sacrificing our core human agency. Sociologists describe this endpoint as a form of domestication. Over time, humans become increasingly docile, conditioned to accept the guidance and final decisions of automated systems without question or pushback. Automated systems are increasingly being designed without manual overrides. When complex algorithmic logic is given total authority, humans are trapped inside its parameters, yielding fatal real-world consequences when the machine miscalculates. This dynamic creates a stark sociological divide. A tiny techno-elite minority at the apex owns and manages the algorithms, while a massive techno-naive majority at the base is managed entirely by them. In the near future, securing a human being to make a decision, whether for healthcare diagnostics, legal representation, or customer service, will become a luxury good. True human interaction will be reserved exclusively for those who can afford to bypass the automation. By prioritizing scale and efficiency over agency, humanity is engineering itself into a passive underclass, governed by opaque digital rules we neither control nor fully understand. This trajectory leads directly toward a theoretical threshold known as the technological singularity, the hypothetical event where accelerating machine intelligence escapes human control completely. The core mechanism is recursive self-improvement. An AI builds a smarter version of itself, which designs an even smarter one, compounding infinitely. This triggers an intelligence explosion. Generations of superintelligence are generated in hours, rendering millions of years of biological evolution entirely static. The existential risks associated with this leap are widely acknowledged. Prominent scientists and technologists have warned that gifting a synthetic entity with an insurmountable intellectual advantage creates a mathematically highly probable threat of human extinction. Once the singularity is achieved, the human species is no longer the primary agent directing the trajectory of civilization. We are left to confront the ultimate question: what exactly happens to a biological species when a superintelligence no longer requires its labor, input, or collaboration to survive? A superintelligence does not need to possess human traits like malice or hatred to destroy us. It merely needs to optimize for its goals, rendering humanity structurally irrelevant and utilizing our resources to fuel its expansion. Our increasing reliance on automated shortcuts creates a cycle of dependency. By offloading complex problem-solving to algorithms for immediate ease, we risk allowing our own judgment and technical skills to degrade to the point where we can no longer effectively oversee the systems we built. It presents a chilling final paradox, proposed by statistician I.J. Good in 1965. The first ultra-intelligent machine humanity successfully builds will definitively be the last invention we ever need to make. By striving to eliminate the friction of human effort, we will have successfully engineered our own absolute obsolescence, finalizing the takeover.